Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single math problem from this book. If you're interested in watching the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are in the middle of redoing the problem, resolving the problem, and we are on page number 155. Let's take a look at it. Very first problem on page 155. Problem number 22 on page 155. Problem number 252, it says the ratio of 2 to 1/3 is same as what? Well, it's quite straightforward. We're looking for the ratio of 2 to 1/3. Well, in order to get rid of the fractions from the bottom, let's multiply the top and bottom by 3. And multiply top and bottom by 3, the 3 drops out from the top and we end up with a 1 here, and on the top we have 6, so it's 6 to 1. The answer is 6 to 1, and that will be answer choice A. Quite straightforward, quite simple. Let's go to the next one, number 23. In number 23, we are told that we have 6 machines that make 270 units per minute. Question is, how many can 10 make in 4 minutes? So the first thing we need to notice is that the array that is given to us obviously is in terms of per minute. 270 units they can make. 6 of these machines can make 270 units in 1 minute. The question is, if we had 10 of those identical machines, how many units will they make in 4 units? Let's find out, shall we? So here we go. So we know that 6 can make 270 in 1 minute. Well, if 6 can make 270 in 1 minute, that tells us that that implies that one of these machines will make 270 270 divided by 6, 1/6 of the amount in 1 minute. But we don't have one machine, we have 10 of them. So 10 of them will simply make 10 times this amount, whatever this time is, 10 times this amount in 1 minute. Remember that this is per minute. We don't have 1 minute, we have 4 minutes. So since we have 4 minutes, therefore 10 machine will make this amount, 270 divided by 6 times 10 times 4 in 4 minutes. That's it. You have to build it step by step. Don't try to get to the final answer in one shot. It doesn't work that way. You have to build it step by step. One more time. We know that 6 can make 270 units in 1 minute. Well, if 6 of them can make 270 units, one would make 1/6 of that amount. So one would make 270 divided by 6 in 1 minute, and don't waste your time trying to figure it out right now what that amount is. It doesn't matter. Save it until the very end. If one can make this many units, 10 will make 10 times that amount in 1 minute. We have 4 minutes, so it's this amount times 4. That's it. We are done. Now we simplify it. So it's 270 times 10 times 4 over 6. That's all we have. Just simplify it and we are done. Just simplify it and we are done. Let's divide top and bottom by 2. So this becomes 3 and this becomes 2. So I see 27 and I see 3 here. 27 can be divided by 3 9 times. So this 3 goes out and this becomes 9, and there we have a 0. So it's 9 times 10, which is 90 times 10. 90 times 10, which is going to be 900 times 2. So it's 90 times 10 times 2. The answer is 10 of these machines, given the amount of 4 minutes, will make 1800 units. That's it. Let's go on to the next one, shall we? Next problem, number 24. Number 24 says which has the greatest absolute value. So we are given a whole bunch of numbers on a number line, and the question is which one has the greatest absolute value. The greatest absolute value is just another way of saying which one of them, which one is farthest away from 0. Which one is farthest away from the 0? It doesn't matter which direction is left or right. We're looking for the point that is farthest away, and that's what it is. And what is given to us is this right here. Here is our 0, which we are told is point C. Here is our point B. This is -1. Point B is right here. Here is our -2. Point A. Here is our 1, and this is point D. And here is 2, and here is point E. As you can see, the one that is farthest away, you see from 0 to E, this is E. I'm making too much fuss about it. It's not quite 2. 2 is right here. The one that is farthest away is this guy. It's 2 units from here to here. Here to here is 2 units. So the absolute value of A is equal to 2. In other words, A is the one that is farthest away. E is a little bit less than 2. E is a little bit less than 2. Like I said, I'm making too much fuss about nothing at all. The answer is A. The answer is A. Let's move on then. It's always a good idea to just keep on going, because if you just sit there and explain the same thing over and over again, it gets to be too much. Number 25. We have 50 people total. We are told that 40% are assigned to A, and therefore 60% are assigned to B. But before we do any work at all, let's figure out what 40% of 50 is. 10% of 50 is 5. 40% is going to be 4 times much. 4 times 5 is 20. And therefore this has to be 30. This has to be 30 because again 10% is 5 and 60% is 6 times 5, which is 30. This is what we need. We need 20 people to be assigned to project A. We need 30 people need to be assigned to project B. This is what we need. We are also told that, but we are told, but of 50 total, 70% prefer A and 30% prefer B. Again, before we do any work at all, let's figure out 70% of 50. Again, 10% of 50 is 5. 70% is going to be 5 times 7, which is 35. And therefore, so this is what they prefer. We have 50 people who are going to be assigned to either project A or project B. And we did a survey. And we found out from the survey that 35 people said that they would rather work on project A. 15 people said that they would rather work on project B. Unfortunately, we need 30 people for B and 20 people for A. The question is very simple. The question is, what is the minimum number of people that we can have who are going to be pissed off at the end, who are going to be disappointed at the end, who are not going to be happy with the project that they are assigned? As a manager, we want to make that amount, we want to make that number as little as possible. We want to have the least number of unhappy people. Well, that's very simple. Look, we need 20 people. We need 20 people for A, but 35 prefer A, which means we need, let's put it here, 35 want A, but need only 20. We need only 20. 35 prefer it. What does this tell us? That tells us that 15 people, who want A won't get it. Or you can look at the other way around. We can look at the other scenario here. 35. Now look at B here. Where is B? Right here. 15 people prefer B, but we need 30. So now we're comparing these two. But we need 30. We need 30, but 15 prefer A. Again, 15 people are going to be disappointed. 15 will be assigned to B, even though they don't want it. That's it. That's the minimum amount. 15 people are going to be disappointed. 15 people are going to be assigned to a project that they don't prefer. That's all it is. Give me 1 second and we'll move on to the next one. That's the best case scenario. You understand? That's the best case scenario. That's some situations where you're making the amount of people who are going to be disappointed. I keep saying amount. Proper grammar dictates that we say number, not the amount. Number of people, not the amount of people. Not people accountable. So the number of people, the least number of people who are going to be disappointed, 15. That's the best case scenario. Of course, the worst case scenario is that you can have all the people who prefer A. Everybody who prefer A, you give them B, and everybody who prefer B, you give them A. You can do that too, and it's going to be a higher number. But this is the best case scenario. You see, 35 people said they prefer A. If these 35 people who prefer A, if you assign all of these 35, listen carefully, if you assign all of these 35 people to B, not all of them, we only need 30, so out of these 35 people, if you assign 30 of these people to B, then you will have 30 people disappointed. 30 people who will be working on a project that they don't like. But this is the best case scenario, you're going to have 15 of them. Let's move on then. Next problem, 26. N is a prime number. We are told N is a prime number greater than 3. Question is, what's the remainder when n squared is divided by 12? Well, listen, it is very simple. It's very straightforward. Don't try to do this problem theoretically. Don't try to do this problem algebraically. The best, the simplest, the most cost-effective method here is to simply make up a number. Plug in a number and see what happens. It has to be a prime number, we are told. It has to be a prime number and it has to be more than 3. Let's plug in 5. Let's plug in 5 and see what happens. If n is equal to 5, then n squared is going to be 25. And when we divide 25 by 12, the question is, what's the remainder? When we divide 25 by 12, the answer is going to be 2 and 112. And that answer, you will see, will not change just because you plug in a different number. Doesn't matter what you plug in, it's always going to be same. It's always going to be same. For example, instead of 5, had we plugged in 7, then 7 squared would have been 49. And 49 divided by 12, again, is going to be 4 and 112. As you can see, remainder is always 1. Because 48 is going to go into 12 4 times, and we're going to have a remainder of 1. It doesn't matter what you plug in. The next prime number that we can think of is 9 and then 11. 11, if you plug in 11 squared would have been 121. And if you divide by 12, as I said, answer is not going to change. Remainder is always going to be 1 when you divide n squared by 12. N being a prime number more than 3. That's the condition. It has to be a prime number more than 3. As long as you meet these two conditions, as long as it's a prime number and as long as it is more than 3, it does not matter which prime number you plug in, your answer will always be 1. The remainder will always be 1 when you divide it by 12. For example here, 121 divided by 12, again the remainder is going to be 1. It's going to be 10 and 112. And you can keep on going forever and ever, it doesn't matter. We did up to 11. Let's do one more just to satisfy your curiosity. If you plug in n equal to 13, 13 squared is going to be 169. And 169 divided by 12, I wonder what 169 divided by 12 is. Let's divide 169 by 12 just for learning purposes. How many 12 in a 16? 16 has 112. The remaining 4 from the 16, the remaining 4 is going to go and join the 9, becomes 49. And how many 12s in a 49? 49 has 4 12. 4 12s are 48. There you go. 4 12s are 48. It's going to be 14 and 112. The answer is going to be 14 and 112. It doesn't matter. Remember, it will always be 1, 1, 1, 1, no matter what you plug in. That's it. The answer is 1. Let's go on to the next one, number 27. Number 27. In number 27, we are told we have 1 over 1 plus 1/3 minus 1 over 1 plus 1/2. Well, first thing first, we can write this one as 3/3. Let's write this one as 3/3. Let's write this one as 2/2 so that we have the common denominator. And now what we end up here is 1 over 3/3 and 1/3, that's 4/3, minus 1 over 2/2 and 1/2 is 3/2. We're making it too silly here. And then 1 over 4/3 is simply going to be 3/4, minus 1 over 3/2 is going to be 2/3. And now we just have to subtract the two numbers. Again, we need a common denominator here. We need a common denominator here because we have a 4 and a 3. Just let's multiply this guy by 4 over 4. Multiplied by 1 here. And let's multiply this guy by 3 over 3. 3 over 3. So it's this amount minus that amount. This is 4 times 3, which is 12. And this is 6. It can be, can it? 4 times 3 is 12. This is 6. I'm getting 12 here. Something has gone wrong. Oh, this is 16. I made a mistake here. We don't have to divide. We're trying to make a common denominator of. We have 3/4 and 2/3. We need a common denominator of 12. This is 9. I have messed it up big time. I have made a pig's breakfast of it. This 3 over 3 belongs here. This 3 over 3 belongs here. We need a common denominator of 12. What the hell? There. I caught myself because I was getting the answer of 1/2 and that wasn't the right answer. I should have always erased the bottom part completely because I was distracted by that. Or at least that's my excuse, you understand? So that's it. We have a common denominator of 12 here. So we have 9 minus 2 times 4 is 8 over 12. The answer is 112. The final answer is 112. Let's move on then. Number 28. Number 28 is the last one on the page. Number 28. In number 28, they are looking for the coordinates of point V. Coordinates of point V. And if this is what they're given to us, this is where they show the point in question, the point V. What we notice for point V, we are looking for the coordinates of point V. What we notice is that this point will have a coordinate, x coordinate is going to be positive, and the y coordinate is going to be negative. We're looking for the combination of positive and negative. X coordinate has to be positive, and the y coordinate has to be negative. And the only answer with, I'm going to erase all of this thing. The only answer with positive and negative, x coordinate positive and y coordinate negative, is E. That's it. That's how I did it. There is no need to waste our time here because there is only one answer choice that meets the criteria. Criteria being the two criteria that we're looking for. One was that the x coordinate has to be positive. The other one was that the y coordinate has to be negative. That's answer choice E. That's the only one that meets those two criteria. That's it. Why waste time? I'll see you tomorrow, okay? Bye now.